Second time already record this video. Okay, so hi everyone, it's Elena Litvinova, and in this video we will study binary trees. Yoo-hoo! Binary trees. Actually, this is special data structure. We will understand what is binary tree, create an implementation in JavaScript of binary tree. We also will add some methods to add elements in binary tree, and also traversals, which is one of it is breadth first search, and second one depth first search. And for depth first search, we also will study inOrder, preOrder, and postOrder approaches. Everything we will test in the browser. We will put breakpoints, we will look on call stack, how everything works. So you will be able to understand everything as deeper as it possible. Let's start. But before, of course, not forget to subscribe on this channel, press bell icon, and go. Psh. Okay, what is binary tree? So a binary tree consists from the root. Actually, each element it is not. No, it is a structure which can contain value or something inside of it. We will use numbers. Also, we will work in this lesson with binary trees. So it means that each node will have only 2 children. And when you create a binary tree, for example, you start from 8. So from the left side, you have to put smaller values. From the right side, you have to put larger values. If, for example, the value is equal, for example 8, and you need to add in your binary tree the same value, there are different approaches. Sometimes you just not need to put that, or you just need to put from both sides, left or right, how you decide to do that. So the first element from which we start, this is root element. We start from root element, and after it we try to put all elements depend on root. And so let's try to create our binary tree and add some methods for working with this tree as well. So I already have the code. Everything is ready. So there are articles which I use for preparation for these lessons. You can read it. And also there is index.html file, because we will work with console. And it's really cool, because we will be able to see the whole tree, and also we will play here with call stack, scope. We'll put breakpoints here. So in the browser, actually it's really quite comfortable, because I decided to create index.html file and start everything through browser. So first of all, we need to create a node constructor, and here we need to pass value and how our node will looks like. Okay, before I just try to show you how usually binary trees looks in JavaScript in the code. For example, we have my binary tree, so it will look someone like that. For example, 8, 7, 9. So root, we usually will start from root. Inside of it we have value, which is, for example, 8. We have right, which is also the same format as, for example, 9. Left null, for example, right null. Yes, and from the left we also have something around it, but which is less, smaller element. We remember that binary tree should to create in the left we put smaller element, into the right greater elements. So, and like that this tree looks like. So after it here it's also will be able, can be an object, and inside it will be a value, left, right, and etc. And it's like a real tree. Yes, so like that binary tree looks like in JavaScript, and we need to create something like that. Firstly, we need to create a node. Node, it is this structure, value, left, right. It's just one node, and this is have value, which is value, and by default when we create a null, this left is equal null, this right is equal null. Yes, and that's it. After it, binary tree. So first of all, we need to create constructor. I suggest that we can pass here, you know, a tree which we have, and just to like provide something which we already have. But let's start from nothing. But we just define root, and it will be null for first. After it, we need to add a method with value, which will add for us elements like that, 8, 7, 5, 2, 6, 9, 10, 11, dribble. So, and how we will add it? Let's reload our browser and check what we have here. Yoo-hoo, we already have binary tree, but method add we call it, but we do nothing here. So here we need to create const new node, which is new node, and would have value. So we create a node. After it, what we should to check? If this root not exist yet, not exist, what we should to do? We should to say this root is equal new node and return. So if we save this code, we will see that we have root, we have value inside of it, and left and right leaves children. Okay, what next? Go. So after it, if for example we already have root, we need to decide where to put it. Our new node, left or right, or I don't know. So, and for that we need somehow to go through all our tree and check and put. So we need to create current node, which is not new node, this root. And inside we have a loop which works before current node exists. Yes, and inside of it we need to check if current node, actually we need new node value less than current node value. Yes, do you understand? We need to go into the left side. We check if current node left not exist. What we do? We just say current node is equal our new node. Easy. And return. And after it, if it exists, we can't put it. We need to change this part and save current node left side. After it, we go through this cycle, through this loop again. And one day, in some period, we actually will find children where there is nothing. And because of it, we really guarantee that this loop really finish, especially if we write else. So for else, if it's another way, new node value more or equal, for now we just write more or equal. So we need to do the same, but right, and right, all right, everything all right. So, and our method is ready. Could you imagine? Reload our browser. So our window is not load a lot, so might be we did everything right, or might be not. Oh, sorry, here it's left. I always have mistakes. Here is right. We need, if we don't have right, we need to put into the right, not to rewrite current node. To be a blogger, it's difficult to write code on the camera. Reload. Yes, works. Yes. Okay, we have root. Inside of it we have left. Okay, value 8. From left we have 7. From right we have 9. Everything is right. From left we have 5. Right we don't have. After it we put 2. We have it from left, and right 6. because we have 5, so it's greater. Put it here. From the right side, 9, 10, 11, 20. Oh my god, let's also do it here, I don't know. Let's put 11 after 20. Might be it will another way. So right, value 10, value 20. From the left we have 11. Yeah, looks right. So how you can see, binary tree looks like that. Really programming tree. So what's next? Next we should to study traversals. So which type of traversals exist for binary tree? It is breadth first search and depth first search. For what is breadth first search? Sorry if I not pronounce it right. I believe that it's possible to break your mouse when you try to pronounce some English words. So for what means traversal? For example, we have a tree. For what we have a tree? Might be we want to do something with this tree, to summarize all values which we have here, or do something with each value. For that we need somehow to go through all possible values which we have in our binary tree. Actually through all nodes which we have. And for this you should use traversal. And there are different approaches for that, and the basis main of it, breadth first search and depth first search. Breadth first search, it means that you pick up first layer, root firstly, yes, after it you check the whole next layer, yes, second layer, level, yes, can I say level or step? After it you check the whole next level, and before you not finish, by width we go, yes, like that. In depth first search you go using one side of tree deeper, check all possible values which you have here. After it, I don't know, for all subtrees you go deeper. After it you go to the right and also deeper, and like that you check it. Because of depth we go into the depth. And for depth first search there are 3 approaches. It is inOrder, preOrder and postOrder. Actually it depends. Approaches is really quite similar, but it depends when you will check your value, before, in the middle, or in the end while you go through deep in the tree. Okay, we will try to look at everything in the code and you will understand everything. So okay, cool, let's try to study next thing. So we already have our tree, and next thing which we should to do to create more methods here. So let's create traverseDFS. Here we have a method and callback. Callback is what we will do with our element. So we will use callback here. And traverse breadth first search. The same. No, we don't have method here. Callback, just callback. Here we will use queues, const queue, and we will start from this root. Actually here we will use approach like for queues, and for if you will not super understand this approach, I really recommend to watch my previous video, which is about queues and stack and queues. Actually really cool video, and I believe you will be able to understand this is much better. So in traverseDFS what we should to do? First let's check current node, this root, and we need to check a method for example, if a method is equal inOrder, we do like that. If method is equal preorder we do like that, and in other case we will do postOrder. So, and here we have inOrderDFS. inOrderDFS, here we will have not callback. After it preorder, preorder and postOrder. postOrder. So, and we need just to call it. You should to return this from not current not callback. If preorder, we should to return preorder, a current not callback. In other case, by default, return postOrder. So, and we have all this function, and let's start to implement all of it. Now let's start to write all methods: inOrder, preorder and postOrder. And what is different in inOrder, preorder, postOrder? So, preorder, when you before do something with the node, actually call callback. After it, you go to the left side, after it to the right side. So next one is inOrder. It means you go to the left side first. After it, when we find the last left element, you do something with the node, and after it go to the right side. And works like that with this tree. And postOrder, when you firstly go to the left, go to the right, and after it you do something with this node, callback. So it's just different in this order. They are very easy and super similar. So if no node, we just do return, because it will be recursion, so we have to create a base case, yeah, when we need to left the recursion. So might be I will create a video about recursion, so you will understand everything. Okay, go next. Inside of it, what we have, this is inOrder. So we need to call inOrderDFS with node left callback. After it, if callback exists, you need to create call this callback with node, and after it go to the right side, Okay, this is inOrder, preorder, when we have actually the same, but we should to do something with the node, call our callback before everything, preorder. And the same with postOrder, but post we should to call this callback after everything. So we wrote our methods, which is super easy. So inOrder, preorder and postOrder, and yes, traverse. And this is our traverse. Let's try to try them. So traverseDFS, call, let's try preorder, and after it pass callback, which will just in callback we will have node, yes. So let's just try console.log node, and I think that I don't console.log this tree, just remove this and this. Okay, 8, 7, 5, 2, 6, 9, 10, 20, 11. Let's not its value, and let's try to go through the code and try to check breakpoints. I will put here this part. Here it's callback. Also put some breakpoints here, and we just look how it works. So we start to work with pre-order. First of all, I'm not sure that no, pre-order, everything is right. So what we have here, there is my face here. Yeah, I know. Let's might be like that. So we have callback, scope, 0, and local and stack call. So we have traverseDFS app and pre-order. So we have node we printed. Go next. We printed this part and we go to the left side. Yes, it means next value will be 7. We print 7 actually. If we go to console, we have to see it. 8. If I call we print 7. So we printed before. After it we go again. We see 5. We go to the left side, yes, and we see 5. Our stack is growing. Next is 2. It is last thing, I believe, yes, from the left. So we go for the left side. Run. We print it. And after it we go up, we pick up values from the stack and go to the right side, because node actually is 0. We return to 5, and after it will be 6, because we remove our stack, go back. So left, there is nothing left, there is nothing right, and go into 7. So we just up by the tree, and if there is any right part, we again go through everything. First print, after left and right. And at the same time, how you see, we print 8, 7, 5, 2, 6, and like that. After it we return to 8 and we go into the right part. So our stack again almost empty, and we go into the right part. So 9, and yes, there is no right, and 20. So after it 11, so 20, we go to the right, we found a left, and go after it we remove, we need to start to remove elements from call stack and go back. And actually we check everything, and our traversal just finished, and that's it. And everything we printed, we have print 8, 7, 5, 2, and etc. So for pre-order we have values like that. Yes. So it is pre-order. If, for example, we use inOrder, it means that we will call this callback between left and right. It will be a little different situation. Firstly, we will go to the deeper 2, and only when we don't have any more left, we print it and go back 5. Also with 6, yes, and after we just printed, so 5, 6, 7, 8, yes. After it we have 9, 10, 11, 20, because this is right part, right side. We don't have left side here, because of it we print 9, 10, 20, this is right side. How you remember, we call in order, firstly we go to the left, and because this is right, we print it. And yes, print 11 before 20. So this is pre-order, this is post-order, and yep, and like that. Post-order. And after it, it's in order, sorry. And post order, actually I can pass everything here, but okay, if it post order, it means that we go to the left, to the right, and only after it we will print. So what we have here, we have an error here. So let's check traversalDFS, postOrder, not callback. Oh, sorry, I forget to do this part. If there is no not, return. So we have 2, 6, 5, 7, 11, 28. So how it again works, let's to go in sources. I remove it breakpoints from preOrder and put in postOrder. And let's start. First of all, we have 8. We go to the left side, 7, 5, 2, finish. Check right side. Actually, there is nothing there, how we remember. 2 is the last element, so we will print it. And go back, 5, also there is nothing from both sides. And we print it. And okay, go, 7 and 8 again. So 2, 6, 5, 7, 8. Source, after it, we go to the right side and left. I believe next will be printed 11. Oh, we not print 8. We need to finish before right side as well, so we will not print 8. So 8 we will print it in the end. So we have 11 and now have to be print. Yes, we go here, run, print, yes. After it we go up and print all values, and 8 will be last. Yes. So postOrder, it will work like that. Yes. Preorder, inOrder, postOrder. So we have studied with you these approaches about depth traversal. For now, let's try to study how to write breadth traversal. So when we go by levels and check everything here, we will work with queues. Actually, it's really easy, I think. So we created a queue, and while queue length, what we do, we just current node, pick up our node, shift from the beginning, pick up node, after it, if callback, we start this callback, we run current node, and after it we need to push if current node left exists, we just do queue push it into the back. Not forget to watch my video about queues and stack. And what we push here, actually, because this is binary tree, we always have, I mean, two children on each node, and for everything of it from left and right side we just need to push, and our queue will be amazing. So here it's right and here it's right. So I think that's it. I hope we will not have any error, and let's try to traverse breadth first search. We don't have methods here, just call back. And let's check what you have. Actually, it have to first print 7, 8, after it's 7, 9, 5, 10. Let's check. Okay, let's check. Actually, I want to do something like that. Okay, 8, 7, 9, 5, 10, 2, 6, 20, 11. Amazing, amazing. Everything works right. So this is traverseBFS. I hope this video was really cool for you. You like it. Also, I provide in the description under this video these links, so you will be able to read more about binary trees. Of course, not forget to subscribe on this channel, press bell icon, like button, and see you in next video with your Elena Litvinova. Bye bye.